Python for data science, a comprehensive overview. Python has emerged as one of the most versatile and powerful programming languages for data science. Its simplicity, readability, and a rich ecosystem of libraries make it the go-to choice for data analysts, scientists, and engineers. It's the key to solving real-world problems, making informed decisions, and discovering insights that can drive innovation and progress in various fields. Data cleaning and preprocessing in Python. Data cleaning and preprocessing are essential steps in the data science workflow. The key concepts and techniques for data cleaning and preprocessing in Python. Importing data. Begin by loading your dataset into Python. Handling text data. Text data may require special preprocessing for natural language processing (NLP) tasks. Documentation. Maintain clear documentation of the steps taken during data cleaning and preprocessing to ensure transparency and reproducibility. Data visualization with Matplotlib and Seaborn. Data visualization is a powerful tool in the data science and analytics toolkit. In the Python data science ecosystem, Matplotlib and Seaborn are two of the most popular libraries for creating a wide range of data visualizations. Introduction to Matplotlib. Start by introducing Matplotlib, a versatile and customizable plotting library. Seaborn's categorical plots. Cover Seaborn's categorical plotting functions, like bar plots, count plots, and point plots, which are useful for visualizing categorical data. Exploratory data analysis, EDA, with Python. Introduction to EDA. Explain the importance of EDA in the data science workflow and how it can guide subsequent analysis. Time series data EDA. For time series data, explore techniques specific to EDA, including time series decomposition and autocorrelation analysis. EDA in real-world projects. Showcase case studies of EDA applied to real-world datasets, such as analyzing retail sales data or exploring trends in health and demographic data. Statistical analysis with Python. Introduction to statistical analysis. Explain the importance of statistical analysis in data science and its various applications. Statistical analysis in real-world projects. Showcase case studies where statistical analysis is applied to real-world datasets, such as A/B testing, quality control, and social science research. Machine learning with scikit-learn. Introduction to machine learning. Provide an overview of machine learning, its applications, and the different types of machine learning algorithms: supervised, unsupervised, reinforcement learning. Setting up scikit-learn. Guide readers on how to install scikit-learn, set up a Python environment, and import the necessary libraries. Natural language processing, NLP, with scikit-learn. Explore how scikit-learn can be used for text analysis and NLP tasks, such as sentiment analysis and text classification. Deep learning with Python and TensorFlow, Keras. Introduction to deep learning. Provide an overview of deep learning, its significance, and its applications in various domains, including computer vision, natural language processing, and reinforcement learning. Setting up TensorFlow and Keras. Guide readers on how to install TensorFlow and Keras, set up a Python environment, and import the necessary libraries. Building neural networks with Keras. Introduce the Keras library for building deep neural networks. Cover the basics of feed-forward neural networks, activation functions, and loss functions. Time series analysis with Python. Time series data is a sequence of data points collected or recorded at regular time intervals. Time series analysis is a valuable skill for making predictions and informed decisions in various domains, and Python provides a powerful environment for performing these analyses. Feature engineering in data science. Feature engineering is the process of selecting, transforming, and creating relevant features, variables, from raw data to improve the performance of machine learning models. It plays a crucial role in data science, as the quality of features significantly impacts the model's ability to extract meaningful patterns from data. Data science best practices in Python. Data science is a multidisciplinary field that involves collecting, cleaning, analyzing, and interpreting data to extract meaningful insights and make data-driven decisions. Python has become a dominant language in data science due to its rich ecosystem of libraries and tools. Real-world data science projects with Python. Predictive maintenance for equipment. Explore how to use historical equipment data to predict maintenance needs and prevent costly downtime. Sentiment analysis for social media data. Develop a sentiment analysis project to gauge public sentiment on social media. Conclusion. In conclusion, Python is a versatile and powerful programming language for data science, offering a vast ecosystem of libraries and tools that make it a go-to choice for data analysis, machine learning, and more. The knowledge and skills you gain in Python data science will enable you to extract valuable insights, make data-driven decisions, and contribute to solving real-world problems in various domains.